Hello there. In this video, I will try to recreate lift system present in Elden Ring. And at the end of the video, the final result would look like this. Also, I will show you how to change the lift's travel speed in the editor, button activation speed, and these two variables. Now, before I go to the blueprint and start writing code, first let's jump into the game and see how it works. So here is a lift, and if I step on trigger plate, the lift starts moving, and now I can't press the trigger plate again. But when lift stopped, then I can reuse it again. Okay, but if I activate the lift again, now when it stopped, the trigger plate won't come up. To make it work, I had to step out of it, and now it goes up. Also for the levers, I will explain it later, but first let's focus on this part. So let's break this down. The lift here has two locations, and whenever character, I mean this player character, when it steps on trigger plate, the plate goes down, and then lift goes up. When it reaches the second location, the lift check continuously that is character standing on trigger plate or not. If character is not standing on it, the trigger plate goes up, and now lift is available to use. So we can divide this problem into four parts. First is make the lift to toggle between two locations when character is standing on trigger plate. Second, move the trigger plate down and then start the lift. And after lift stops at another location, then move trigger plate back up. Third is make lift only available when trigger plate is up, so player cannot activate the lift in the middle. And fourth is make the trigger plate to go up only when character is not standing on it. Also, to keep it simple, this lift is designed for single player game only. So let's do the first step. For this project, I am using basic third person template, and in this lift blueprint, I already added these two meshes. These are simple cylinder meshes, and in the middle, this box collision. So now to move the lift between two locations, we need two vector variables so lift can toggle between them. The location 1 would be the default location of this sector, and for location 2, I need this variable to be editable from level viewport, so we can easily identify where lift will end. For that, this variable would be instance editable and show the widget is true. The instance editable checkbox makes it editable from here, and show the widget checkbox makes it visible from viewport. And the default value of it would be, let's say, 1000 units on z-axis. Now if you think location 1 is defined in begin play and location 2 is defined in editor, and when we move left from location 1 to location 2, then left will go there, right? Well, no, it will go somewhere else. Actually, it depends on how you implement it though. I will explain why in a minute, but first let's make this left move. For that we will apply begin overlap on this box collision. Also I will uncheck this so you can see it in viewport. Now let's move this left, and for that I will use timeline. Inside the timeline, the length of the track will identify how long it will take for the lift to move from one location to another. Now to move the lift, we need simple flow track. In it, right click to add 2 points. First one is a time 0 and value 0, and another one time is 3 seconds, the length of the timeline, and value is 1. Okay, now to move the lift between two locations, I will use lar function. Also make sure to get the vector one. So basically what lar function do is, it gives the value based on an alpha. If it's 0, then it gives value A. If it's 1, then it gives value B. And if it's in between, then it gives value based on that. And now what we are moving is this sector. Let's connect all this. Now if I play and step on trigger plate, then lift moves, but it moves to a different location. The reason for that is this variable here, as you can see, the x and y axis are 0 and we only change the z value. So if I draw this vector by using draw debug sphere, let's give it some color. Now if we play, then you'll see it's actually in that location instead of here. To fix that, we need to add actor location with location 2 and overwrite it, because this variable here in the editor is actually actor location plus 1000 units on z-axis. So let's do that quickly and begin play. And now if I draw, you can see it shows at correct position. And left also moves to correct location 2. Also, one more thing I want to show you. You can also use set relative location of left base static mesh. If you use this function, then you don't need to set any of these values here. If I do that, then it works. But for this tutorial, we will move the whole actor. Now let's toggle the left between these two locations. And for that, we need a boolean value to identify on which location this left is at. The default value of it is true because left is always at location 1. Now I will do here a simple branch. And if left is a location 1, then it moves to location 2. And if it's a location 2, then it moves to location 1. Also, when this timeline is completed, then this variable is toggled. Now left goes up and left goes down. Before I go to the next step, I would like to keep it organized. So I will create a new function, toggle left location, and because timeline can't be used inside a function, like if I try to copy it, it won't get copied. So in this case, I will use two custom events. One event is this, and another one is this. Now let's cut all of these nodes to here, and we don't need these. Now in toggle left function, if left is at location 1, then move to location 2, or else move to location 1. Now for this variable, I will create a new function, toggle left location data. Also, to get branch node quickly, just hold P key, then press left button. Now if it's true, make it false, and if it's false, make it true. Now these two functions called from here. Also make sure to categorize variables and functions correctly. And I will also make them private. You don't have to do that, but I prefer it that way. Over the timeline, I will select both of these points and make them auto by pressing 1. Or you can right click and do it in that way. This would make left to move smoothly. Also, comments are important. And if you don't know, you can actually save the color here, which I already have that. Now if we play just to check if anything is broken or not, then left moves and it also goes down. In the second step, we need to move the trigger plate down when character steps on it, and then start the lift. And when lift reach the second location, then move trigger plate back up, which means trigger plate should have two variables. One is for initial location and one is for trigger plate press location. Initial location would be the relative location of trigger plate, and for press location, I want it to be pressed by, let's say, this much. Now to move the trigger plate, I will not use timeline. Instead, I will use move component to node. What this node do is, it moves the component, which is any of them, to their relative location, and these values are relative values. I will use the custom event. The reason for that is, this node here can't be used inside a function. Now we need a variable to check is trigger plate available to press or not. and by default trigger plate is available to press. Now we need to select the related location of trigger plate based on this variable. For that I will use select function here, and if this variable is true, when player steps on trigger plate, then plate moves to press location, else it moves back to its initial location. Also component we're moving is the trigger plate, and check the ease in and ease out, and time it takes to press would be 0.5 seconds. Also I will create a new function to toggle this variable. Now let's check trigger plate goes down or not when player steps on it, and it goes down. Great. Now let's connect all the logic. So when character overlaps this box collision, then trigger plate is pressed. After it's pressed, then it toggles trigger plate state. Then toggle the lift location, and then it toggles this variable. And when lift reaches the another location, then it toggles the trigger plate again, which moves trigger plate back up. Now you might have guessed that it would be infinite loop, and when lift reaches the another location, then it moves again. To fix that, lift will only toggle location when trigger plate is pressed, or you can say when trigger plate is not available. After that, let's check it's working or not. So when lift stops, then button goes up, and when character steps on it again, then lift goes down. But the problem with this setup is when lift is moving, then if character steps on it again, then it behaves like this, as you can see, and this problem is handled in third part. So let's get to it. In this step, we need to disable the lift when trigger plate is pressed. So player can't activate the lift again when stepping on trigger plate. So before doing anything, let's analyze the variables. If I open the blueprint debugger, now if I play it, you just have to look at this variable here. Trigger plate is available right now. If character steps on it, then it becomes false. And it stays false until lift reaches a top location, and then it becomes true. Same if it goes down. So we can use this value here as a check. And now if I play it and character steps on trigger plate again when lift is moving, then trigger plate is not available, so nothing happens. Also, if you is curious about the debugging tools, well, I will not explain them here, but you can watch this video. It explains the debugging process in pretty good way. Now in the fourth and final step, we need to lift the button only when character is not standing on it. For that, I will use a boolean variable which becomes true when character stands on trigger plate. Actually, it is when character overlaps with this box collision, and will become false when character steps out of it, and by default it is false. So the logic would be when character steps on trigger plate, then it becomes true, then lift starts, and when lift reaches the another location, then lift will check this variable continuously, and if it's false, then the trigger plate goes up, and then lift is available to use. So how do we make lift to check continuously? We can use the event tag, but there is a better node which is set timer by event node. What this node do is it calls whichever event is connected here, and this time represents how long it should wait before it calls the event. Like if I connect it here and connect an event and print something and then toggle the plate. Now when lift reaches another location, then it calls this event, and after 2 seconds it toggles the trigger plate. So the logic would be when lift reaches the second location, then it checks this variable continuously, and if character is not standing on it, then it toggles the plate. Also we need to loop it, and it would check this variable in every zero point 0.3 seconds. Now when lift reaches, then trigger plate won't go up, and if I step out of it, only then it works. But just look at here. Even though I stepped out of it, it's still running, which creates some weird stuff like these. So to fix that, I will promote this to a variable and I will invalidate this timer when character is not standing on it, and then it toggles a trigger plate. Now let's check it. When lift reaches, then it will check this variable continuously, and when character steps out of it, then trigger plate goes up, and now it's not an infinite loop anymore. Now one more thing, the lift will trigger when anything collides with it, like this queue. So just to make sure only character can trigger lift, I will use tags. So in third person character blueprint, I will create a new tag here. And in the left blueprint, if overlapped actor has a tag, which is this one, only then lift will trigger. Also same check goes in and overlap too. Now lift won't get triggered by this cube and only player character can trigger lift. There as you can see it works normally. Also I will have to clean this up a bit. So I will change this event to this name and I will promote it to variable. It's actually not a good idea to have unnecessary magic constants. Also I can't convert these nodes to a function because of this node, but I can convert them into macro. Now just to keep it clean, I will use this macro here also. And I will call this function too. Now if you're thinking, why not place it in the event? Well, the reason is I want this function to run after this node only. If I place it in an event like this and call it here, then what will happen is if I step on it, then did you notice it? Well, let's change plate activation time to 3 seconds. Now you will see. The lift starts the moment character steps on it. If I connect the macro, then look at the execution. After it's completed, only then rest of the logic executes. So it's just that's why I'm not using the event. Now let's add some quality of life improvements. So we can change the lift location in editor and also lift travel speed and button activation speed. So to move lift like this, we need a float variable, which default value will be 0, and to make it a slider, I will add 0 and 1 in here. Now it's a slider, but we can manually edit the value over its range. And to fix that, I will add 0 and 1 in here also, so it would clamp between them. Now this variable will act as your alpha, and it's also instance editable. Now whatever logic we will add, we need it to run when character is placed on the level, and for that we need to apply the logic in the construction script. Now in here we need a node which would give value between these two vectors based on an alpha value, which is this. So guess what node that would be? If you guess the lurk node, then you is absolutely right. And what we are moving is lift base. I will get to that why we are using this instead of set actor location. But first, if you think the logic would be this, well, you is wrong because location 2 value is assigned in the begin play and construction script runs before begin play. And if you look at the editor, then the lift is at world origin. But hey, it moves to at least. So instead of location 1, we need the actor location. And for location 2, we need to do the same thing as begin play. And now lift is at correct location and it works. Also, if you use set actor location, then obviously it moves the whole actor, which is not what we want. Now if you think we're done with it, no, no, no. Because if I move it here, then if I play, lift stays there. Also, lift would work correctly though. But the thing is, we need this to be temporary. So in the begin play, let me organize it a bit. So after all this logic, I will set lift base world location to location 1 because we are using world location in construction script. Now no matter where lift is, it would always start from location 1 and it works correctly. Now that's done, let's change the lift speed and trigger plate press speed. So the thing with timeline is whenever you create a timeline in the blueprint, it's created as a component. So I can use this variable to change the play rate of this timeline. So let's do that in begin play. In here, if I go to components and timeline, I can use this function to change the speed of timeline. Also promote it to variable, and this would be instance variable. So if we change the lift speed by 3 times, then it will be faster. Also default value of it should be 1, and there we go. If it's 0.2, then it's slower. Well, too slow. Now for the trigger plate, it's just this would be instance variable. Now if I change the trigger plate activation time to 0.1, it's pretty fast. If I change it to 1 second, then it takes a whole 1 second. And with that, we're done with the lift. Remember, right now, if lift travel speed is 1, it takes 3 seconds. If it's 2, then it takes 1.5 seconds, twice as fast. And for trigger plate, it's how long it takes to press. Also, these variables are categorized because I categorize them in here. Also, one more thing. Right now, timeline length is set to 3 seconds. But if I change it to 1 and move this second node to 1 second, then if this variable is 1, then lift will take 1 second. If it's 2, then it's twice as fast, etc. Now the lift logic is done, almost. Let's focus our attention on the lever. The lever logic can be applied in two different ways. One, that we make the lever part of the lift blueprint, or we can keep the lever as a separate blueprint. I find the second option harder, so I will create it in that way. I mean, the difference in the second method is the way two blueprints communicate, but the logic would be same. So, because lift only moves between two locations, there can be only two levers. One which handles location 1 and another handles location 2. So when player goes near the lever which handles location 1, then this lever asks the lift which location it's at. If it's a location 1, then both are equal, so nothing happens. But if lift sends location 2, then lever activates and it shows prompt. Then if player presses the desired key, let's say E keyboard key, then it calls the lift to toggle its location and the lift moves to another location. So we can divide it into three parts. As when character is in range, activate lever, in which it show prompt to call the lift. Second, activate the lever only when lift is available to call. And third is when lever is activated, then if player presses the desired key, then call the lift. So before doing that, let's make the lever blueprint. For the lever mesh, I created it in Blender. It's pretty simple mesh, and you can see the origin of these two. So after exporting them separately, I imported these two meshes here as separate meshes. If I drag them, both fits perfectly. For the blueprint, I simply drag them here. Make sure lever base is parent, and I added a box collision. Also make it not hidden in game for now. So first prompt is when character goes near this box collision, then it shows prompt. But the prompt I believe is presented in player screen, which means the prompt widget will be part of the player screen and lever simply tells the third person character to show the widget or not. You will understand why it's in third person character. But first, let's create a simple widget. I will keep the widget pretty simple. So, canvas panel, then border, and I will place the border in here. Now add the text and also make sure in border size to content is checked to keep it compact. And also brush color would be black and alpha 2.3. Also in text make sure it's named correctly and is variable is checked. Now we need to set the text value of it. For that I will create a custom event and set the text. Make sure to use the set text function inside widget category, and this event should have this input. Now the way I will set the widget is in the player character it add the widget which is hidden by default, and if player goes near another object then that object can tell the player blueprint to show the prompt with their own specific text. So if player goes near, let's say lever in this case, then lever tell player to show this prompt, and if player goes near the door then door tell it to show different prompt message, etc. So let's jump to the third person character. Also I'm using version 5.5, so this code is now no longer in gameplay. Let's create the widget and add it in viewport. If I play it now then it would look like this. Also make it full black and let's make it hidden by default. Now we need a way for lever blueprint to tell third person character to show this widget when player overlaps this box collision. Also to change the text to a new one that lever blueprint sends. For that I will use interface. So let's create one. This interface job is to hold function which handles common interaction between blueprints. Now in this function I will create a new boolean variable to show the widget or not, and for text I will create a new text variable because in here it's a text variable. Now when player overlaps with this box horizon then it sends this message to the overlapped actor. It would be true and text would be let's promote it to variable, and when overlap ends then it sends this. In the third person character at the interface, now apply this event, and if it's true then set the text of this widget and make it visible, but if it's false then make it invisible. Now it works like a charm. Great. Also let me rotate it a bit. Now let's activate the lever, which means it show the prompt when lift is available. So to make it happen, lever should check couple of things. First is when lift is available, well it would be when this variable is true. And second is if lever handles location 1, then if lift is at location 2, only then lever is activated. Also considering when player is in range. So in lever blueprint, we need lift reference. So lever can ask for lift location. For that I will create a new variable, lift reference, which is an actor, which is instance editable and its reference to this lift. Also because there are only two locations, sorry, because lift can move only between two locations. So to check that which location this lever handles, I will use boolean variable here. And default value of it is true. And it's instance editable also. Now for lever to communicate with lift, I will create a new interface. One function would be is lift available and it returns boolean variable. The second would be is at location 1 and output would be boolean variable. Now let's add this interface to lever blueprint. In this function it returns this value, and in this function it simply returns this value. Now let's do the check. In lever blueprint I will create a new function, and in this function I will use this lift reference. Also one important thing, whenever you use a reference always convert it to validated get or make sure to use is valid function. especially when that variable is instance editable. Now it's simply calling the interface functions. If lift is available, then it do further check that is it at location 1, and if these two variables are different, which means lift is at location 2, then this function returns true, else it returns false. Also we can use one return node. I'm using it like this for visual purpose only. Now if lift is not available, then it returns false, and if it's not valid, then also it returns false. Simple so far. Now after the comments, I will change things up a little. Like in this event, if it returns true, then it show the widget, else it won't. I mean send the message to show the widget. Also we need the overlapped actor here, so promote to variable. Then it calls this event and connect it to these functions. Also in lift blueprint, I will print string at the end here. Now I will create a breakpoint by pressing F9. Now after character collides, then it executes false branch. And if we check this function, then lift is available, but lift and lever locations are same, so it returns false. But if lift reaches another location, then press F11 to get in the function and press F10 to go step by step. If he is wondering about shortcuts, then they are here. As you can see, lift is available and lift is not a location 1, which means they are different. So it returns true and prompt will appear. But the problem is right now I had to go in and out from this box collision. Let me remove this. Now you can see I had to re-enter this box collision for lever to ask data from left. I will show you how to fix it, but first let's call the left. So when character presses, let's say E key, and left is available, then lever calls the left. For that I already created an input action, and for trigger I added pressed. So when key is pressed, it registered as one key press. In the input mapping context, it's simply added here. Now the third person blueprint, when E key is pressed, then I will use pair overlap actors. The position of it would be actor location, and object types would be world dynamic. So what this function do is, it creates a sphere at actor location and return the array of dynamic objects who got caught in this sphere radius. The world dynamic objects basically are those objects who can be moved by either animation or through direct code. Like if I go to editor, these objects are dynamic objects and this floor is a static object. Like if I print the display name of each object and also draw the debug sphere on same location with same radius, so you can see. Now if I press E key, then it will create the sphere, but right now it won't print anything because this floor is world static. But if I go near left, it prints its name. Same with the lever. If I add physics objects, then it prints these cubes. And if I add static object, then you can see a bunch of cubes. I mean, you can keep these other pins if you want to. There is nothing wrong with that. But now let's get back to the topic. So when E key is pressed, then we need to communicate with the lever. For that I will use interface. In this interface, I will add a new function, basic interact, and I will add it in lever blueprint. For now, let's print something and also call this interface function in third person character. Now if I go near lever, then it works. So let's print it only when lever is active or when it's showing the prompt. So for that Rather than using this function and calculating all of it again, let's create a variable, and by default lever is not active. It will be true in here and false here. Also, if you want to align all of these nodes, just select them and press Q key. But here is another tip. If you select this node first, then select this node, then press Q, then it aligns this node to the second node, as you can see. Also, if you want to align them like this, just play with these. Now it's simple. Add a branch node and add this variable here. Now it won't print any message, but when left is available, then it prints. Now let's call the left. In left and right interface, I will create a new function. Now let's add this interface function, and it simply calls this function. After that, let's call it from lever blueprint, and target would be lift reference. Okay, let's see if it works or not. Lift goes up and it's too fast. Now if I press E, then lift goes down. Also one more thing, right now lever is available, but if I go out of this collision, then if I press E key, then lever triggers and it called the lift. The reason for that is this overlap we are using collides with the lift box collision. To fix that, I will use a new boolean variable. When pair overlaps, it becomes true, and in here it becomes false. Now in this function, if it's true, only then do the calculation, else return false. Now lift goes up and lever is active. And if I go out and press E key, well, it still calls the lift. Can you guess why? Let's check it. In the blueprint debugger, I want you to look at these values. Remember, it uses this variable as a check. If I go in, actor in range is true, but lever active is false, so nothing happens. But if lift goes up, then if I go in, then actor in range is true and lever is active. But if I go out, then lever is still active because this variable changes value in this event only. And we call this event when character overlaps, but we never call it when character ends overlap. So let's call it here. And now nothing happens as expected. And when left is up, then lever is active. But now it works as intended. Now, because the way we set the lever up, if I add the lever on second location, and let me quickly create the platform. Okay, now if I uncheck this, and remember this variable should reference this lift, and now it would work without me doing anything. Before I go ahead, right now there is a bug. If lever is active, and then if I call the lift, then lift goes down, but lever is still active. And if I press E again, the lift starts running again. The problem is if I call the lift down, then right now lever does not know the lift location. If I go out, then go back in, then only this lever asks the lift location. So let's fix that. To fix the situation, we can either make the lever check lift location continuously, like either per frame or per second when actor is in range, or we can leave it to the lift, like lift should send a signal to levers who are listening to it each time it changes location. I will use a second method here. For that, I will use event dispatcher. You can take event dispatcher as a communication system where one object makes a specific call, and whichever object is listening to that call will respond accordingly. So the logic would be lift sends a signal when it reaches another location. The lever is connected to the lift will listen to that call and check should it activate itself or not. So let's create an event dispatcher in lift blueprint. And because lift completes one cycle in here, I will simply drag it here and do a call. Now the way event dispatcher work is listener's object must have the hard reference of the caller. And liver is listening to this call, but right now I can't bind liver to that call. So I will change this to lift variable and then I can bind the event dispatcher to begin play. I will not go in full detail, but the event that connects here, let's say for now this event, which prints a string. So this event will be called whenever this call is called. Also nothing is broken right now because I change it into lift blueprint. Now when lift toggles the location, then it makes a call and both levers responded to it. Also since we're using direct reference of lift, so in lift blueprint I will remove the interface and if I click yes, then it implements these functions as part of this blueprint. Now instead of using interface functions in liver blueprint, I will use lift functions directly. Also if you type function, it shows all the functions available from this object. And if you notice, it won't show these functions and events because they are private. Okay, now instead of calling this function, I can call this function directly. And for that, I will make it public. Now we don't need this interface and let's run it to check is there anything broken or not. And everything works correctly. Now whenever lift reaches another location, then we need to call this function. For that, instead of dragging this pin, I will use create event function and select this function from here. Now let me just create some breakpoints by pressing F9. Now if I play it, right now it would be false. But when lift reaches location 2, then this lift makes a call. And because this call is bind to this function, so this function is called and you can see it returns true. And liver is showing the prompt. If I call the lift, then it's called again. Now one small thing. Well actually it's big. That when lift is going down, then I want this lever to deactivate. Because when lift is going down, then if I call the lift again, then this happens. And now we are stuck. Well, let's figure out what's going on here. If I go to the lift blueprint and then I open the blueprint debugger, then just look at this variable. When I call the lift, then trigger plate becomes false. But if I call it again, then it becomes true. And when lift reaches another location, then it toggles its state again. The reason for that is when E key is pressed, then it straight away calls the lift, which toggles the trigger plate if lever is available. And we only change this variable when this function is called. And this function is called from here, also from here. So when lift is called, we need to deactivate the lever and disable prompt, basically this section. I can drag it here, but it would be redundant code. So let's collapse it to a function, rename this variable, and I will simply call this function here and keep it false. So lever becomes inactive before calling the lift. Now lever is available And when I call the lift, then prompt disappears. Also, just for fun, I can rewrite it like this. Now one last thing. Let's make this handle move, which is pretty simple. Add the timeline, and I will need 3 nodes and make them auto. Now we'll quickly rotate this lever handle. For that we need 2 rotation variables. One would be the initial location and another one we need it to rotate this much. Okay, now same old thing, and this event called from here, and when this is done we call the left, and now it works. Also I will change the handle collision to no collision, and this is it. We are done with this. Now I want to show you a strange case in which if lift goes up, then this lever works. Great. And if I go up and if lift goes down, then this lever activates too. Now the important part, which is if I call the lift and jump down, well, this lever don't show any message and lift is stopped right now. If I go out and go in, then it shows the prompt and it works normally. Strange, right? Like if I start the lift and only when this lift is moving, then if I am in this lever range, then after lift reaches second location, this specific lever won't show the prompt. So this bug only occurs in either of these levers after character collides with both levers box collision. Remember when I said the second method is hard? Well, this is why. Now the bug is this lever won't show the prompt. So let's look at the code which handles the prompt. So in first time this line executes because lift has not reached the second location. After it reaches, it shows the prompt. Now if I go to the second lever, then makes sense that this executes, and when lift reaches down, then both of these line executes. But it is showing the prompt. So let's go to the first lever. And in here now both lines executes and this lever won't show the prompt. But it would work. Okay, right now I haven't collided with any of the levers. I mean their box collision. So when lift goes up, then nothing happens, which means this event does not called. Makes sense, right? But in lever blueprint, if I go there, when lift reaches another location, then it does run. Now you might have guessed that why this called and this does not. But first let's go step by step. Let's print a string here. And in the lever blueprint, I will simply print the display name of this actor so I can see from which lever it is called. Now when lift goes up and I'm in lever 1 range, then it prints these 3 messages. This event is called by these 2 levers because both are listening. But then why this part executed only one time? But if I go to the second lever, then this part executed 2 times. Also the order is important because if I go to the first lever, now first prompt is visible and then it becomes invisible because of this part. Because this part now executed by lever 2 also. If I add a breakpoint here, now if lift goes up, this part executes, but if I hover over it, it's an unknown class. Remember debug object is BP lever 2, but if I change debug object to BP lever, now it's a third person class. But if I change it to validated cat, then you will see it clearly. Also, let me print something. So in the liver to case, this message does not go anywhere because this object only assigned when player overlaps the box collision. But then this object is assigned or when player gets in range of liver 2, then it's called 2 times. And then in liver 1 case, it sets the prompt to visible, but then liver 2 sets it back to invisible. So here what happens in simplest way. Player character has already interacted with these levers at least once. So overlap detector is initialized. Then when lift reaches second location, then it makes a call. And if player is already in lever 1 range, then lever 1 responded, which in turn runs this event, which do the checks, then it tells player character to show the prompt. And then lever 2 responded, which do its own checks, and then it tells player character to not show the prompt. So the explanation is done that why this is happening. Now let's fix it. So the way I will fix it is instead of both levers listening to the left's call, I want only one lever to listen to the left. If player is near lever 1, then only lever 1 will listen to the left. And if player is near lever 2, then only lever 2 will listen. Right now if left goes to another location, then it prints these messages. So instead of binding the event in here, I will bind it in here. Now if lift goes up, and right now I'm not in the range of any lever, so it prints nothing. But now only lever 1 responds. But if I go to the lever 2, it goes back to where it was. Well, because I did not tell these levers to stop listening when player goes out. So let's do that. Now there are two options. In this one, we need to specify the event that we want to unbind. So let's pick that for now. Now only lever 1 responds, expected, and in lever 2, now only lever 2 responds. And if I goes back to lever 1, then only lever 1 responds. Also I need to specify the event here, but what I can do is I can simply unbind all the events from this left and it would work like normal. And now finally we are done with this lift. I hope you learned something new and this is it. So see ya.